Now, fractional exponents. Do they make any sense? We already know negative exponents don't make any sense. How do you take 9 and multiply it by itself negative 2 times? Makes no sense until you learn the rules, right? Then okay, I see how that works. So looking at this, what is the base here? The base is 9, yeah? Agreed? And the exponent says we are going to take 9 and we are going to multiply it by itself half a time. Does that make any degree of sense? Right? I mean, if I told you to take 3 squared and draw it, you could. You would go 1, 2, 3, and 1, 2, 3, and 1, 2, 3. And you would make a square that was 3 by 3, wouldn't you? Like, it's easy. It makes sense. Exponents make sense, right? But this makes no sense. Because how would you draw 9 times itself half a time? You can't. So that's why I've asked you to use your calculator to do this. How do you punch this into your calculator? Same way you punch all exponents into your calculator. 9, exponent button, bracket, 1 divided by 2, bracket, equals. And tell me what you get. 3. Okay. Now do the same thing with 27. 27, exponent button, bracket, 1 divided by 3. And do the same thing with 625. 625, exponent button, bracket, 1 divided by 4. 5. Now you guys should already see a pattern here, shouldn't you? Is there any relation between 9, something to do with powers, and 3? Is there any relation between 27, something to do with powers, and 3? Or any relation between 625, 5, and 4? Can anybody see those relations? What are they? What do you mean, Abresia? Right. So, looking here, what would you say this one is? What's the relationship there? What? 3 squared equals 9, yes? And what's the reverse of that? The square root of 9 is what? 3. Agreed? Okay. What's this one? 3 squared, 3 cubed is 27, yes? What's the reverse of that? Cubed root of 27 is what? 3. Cool? What's this one? 5 to the 4th is 625, yes? Which must mean the 4th root of 625 is 5. Is everybody cool with that? Now, look closely. What do you notice about the index and the denominator? They're the same. So, in a fractional exponent, the denominator, I'm going to be lazy, I'm just going to write denom because I'm a lazy sack, is the index of the radical. Everybody cool with that? The bottom one. Everybody sees that? Now you guys are smart kids. What exponent is supposed to live right there that we don't write down? 1. Agreed? What do you notice about all of the numerators up there? They're 1. So what does that tell you about the numerator? If the denominator becomes the index, what does the numerator become? Becomes the exponent. Does everybody see that? Everybody sees? Everybody understands? Okay, so let's look and see how that helps us. I don't actually want to do A first. I want to come to this one first. Okay? Everybody look at B. It's 27 to a fractional exponent, yes? So the denominator becomes what? The denominator is the index, and the numerator is what? The exponent. And this guy becomes the radicand. Remember, we've used that word before. So what does this look like? Index of 3, 27 as a radicand, to what power? 4. What is the cubed root of 27? 3 to the 4th power. And what is 3 to the 4th power? $81. Does everyone see how it works? Now, it's a new exponent law, isn't it? So can we forget about all the previous exponent laws? Of course not. They all still apply. So let's go back and look at A. Barf. It's hideous, isn't it? Okay. But we know some stuff to deal with that. What does the 2 become? The index. So I'm looking for a square root of something. Square root of what? 0.04. And what am I going to do with that whole number? Put it to the power of 3. Do I know this square root without a calculator? Yes, I do. Because that is the square root of 4 over 100, isn't it? Isn't that 4/100ths? Okay, so what's the square root of 4? 2. And what's the square root of 100? 10. And all that's cubed. Do I know what to do when I have a fraction cubed? Where does that exponent go? To everywhere. So I'm going to get 2 cubed over 10 cubed, yes? What is 2 cubed? 2 times 2 times 2. Don't say 6. 8 over, what's 10 times 10 times 10? 1,000. Which could also be written as 0.008. Is everyone okay with that? The new rule, the only thing new there is what to do with the fractional exponent. You knew, or you should have known, that 0.04 was 4 over 100, and then you should have known how to square root all that. That's not on me. That's up to you guys to know that already, right? All right, let's look at C. This is a perfect example of what I was just talking about, yes? Can I forget about all the previous exponent laws? No. Is there a previous exponent law in here that I could use right now? What is it? Exponent over brackets, isn't that? So what is 1/3 times 2? 2/3. So I have 8 to the 2/3. Now, can I use the new exponent law I just learned? Which is what? I've got 8 to a fraction of 2/3. I know that the denominator and the numerator need to do something. What do they need to do? 3 turns to the index. What becomes the radicand? 8. And that whole expression is to what power? 2. Do we know the cubed root of 8? It's 2. 2 squared is what? 4. Everybody got it? Now, tell me in this white space over here, because you should have a little bit of space, is there another way you could have done that wasn't this exponent law? Don't you know that? You know that is the cube root of 8, don't you? So that was 2 squared, which was 4. Why did I show you both? Because some of you aren't going to see these moves right away. You might not right away notice that 8 to the third is the cube root of 8, especially when the numbers get bigger. Understand? So the key to solving these is always apply as many exponent laws as you can, because that always makes it a little bit simpler. Okay? Everybody with me? All right, so let's look at the next one. What have I got there? I have a base to a fractional exponent. So what happens to the denominator? Index. So I'm looking for a square root. Where does the base go? Becomes the radicand, right? Now we don't like this, do we? So I'm going to make it 49 over 100. And all that is to what power? Look again. 1. Do I need to write it? No. So what is the square root of 49? 7 over what? 10. And what's that as a decimal? 0.7. Everyone cool? Now I want to show you guys something that you should have learned again in grade 9. I just want to remind you of it. Is there a square root of 36? 6. Agreed? Is there a square root of 3.6? No, that's irrational. Is there a square root of 0.36? 0.6. Why? Because that is 36 over 100, isn't it? Okay. Is there a square root of 0.036? No, that's irrational. Is there a square root of 0.0036? Yes, it's 0.06. What are you seeing? There's a pattern. What is it? That had a square root, that had a square root, and that had a square root. What about them gave them the square root? Even number of decimal places. That's the shortcut you guys are going to take away from that, right? That's probably what your grade 9 teacher taught you, if he or she taught you this, which he or she should have. But what is really happening there? Has it worked in the past to memorize a bunch of shortcuts? Yeah. What's happening all of a sudden in math now? It's getting a little more complicated, yeah? And those shortcuts are starting to pile up on each other, right? It's like how somebody gives you really complicated directions to a place. Go 3 blocks, then turn left, and go another 2 blocks, turn right, then go 3 more blocks, take a slight right. It's a pain, isn't it? Right? Don't memorize shortcuts. Don't memorize shortcuts. Look at what you're doing. This is 36 over 100, right? What's this? 36 over 1,000. 1,000 doesn't have a square root. This is 36 over 10,000, which does have a square root. Picking up what I'm putting down? Know what you're actually doing. Don't know a shortcut. Okay? So, let's look at 16 there. 16 to the 1.5. What? To the 1.5. Well, wait a minute. I know what to do with fractional exponents. What are decimals? Aren't decimals just fractions? So what is this guy as a fraction? It's 1.5, isn't it? How do you turn that into a fraction? It's 3 over 2, right? So this is really 16 to the 3 over 2. And now all of a sudden we can do this, can't we? Where does the 2 go? Index, 2. Where does the base go? Radicand, 16. And all that is to what power? 3. What's the square root of 16? 4 to the 3rd power. What's 4 times 4 times 4? You should memorize the first cubes. 64. You guys do that one. Decimal exponents don't work. So what do you got to change it to? Fraction. What fraction is it going to be? 75 over 100 would work, but wouldn't it be better to do it simplified? 3/4? Because I don't know about you, Sammy, but I don't know the 100th root of 81. But I do know the 4th root of 81. 4th root of 81 cubed. What is the 4th root of 81? Most of you, I haven't taught you how to find 4th root on your calculator. Some of you won't know how to do that. So you got to use your head. I have taught you how to simplify. Isn't 81 9 times 9? And isn't 9 times 9 3 times 3, 3 times 3? Isn't that a group of 4? So what's the 4th root of 81? 3 cubed. What's 3 cubed? 27. Everybody good? Now, I want to do 2 things now. One, I would like to discuss with you how you find a weird root on your calculator. Who doesn't know? Like if I want the 5th root of 32, who doesn't know how to do that? There's probably a few of you, yeah? Okay. Look on your calculator for one of the following keys. X to the 1 over y, or x root y, or y root x, or blank root x, or blank root blank, or y to the 1 over x. Find one of those. Every one of you should have it, either as a button or a shift button. Does everybody have it? Okay. So now it's up to your machine. All right. If you have a forward calculator from Trig, remember Trig? If you have a forward calculator, you're going to push 5, whatever button you have. I'm going to do the XY button. 32, and you probably have to push equals. If it's a backwards calculator, I think, because I haven't had a backwards calculator since 1990, I think you just reverse it. 32, then whatever your weird button is, 5. And your answer is what? 2. Can everybody do that? Everybody's able to make their calculator find them crazy roots. Oh, yeah, you've got to go into math, I think. Adidia, you got to do this. You will push math, and then there is your crazy one. See? X with the blank root. So you need to do this. You will need to go 5, math, 5 again, 32 equals. Got it? Okay. Everybody Gouda? All right, that's the first thing I wanted to show you. The next thing I wanted to show you is this. To do this on a calculator, because 8 doesn't, this is really the 5th root of 8 squared, isn't it? But 8 doesn't have a 5th root, does it? That's going to be irrational. So you got 2 ways to do this. One, you can convert it to this and use the 5th root button, or you can do what you already know how to do, which is 8 exponent bracket 2 divided by 5. I don't care which way you do this. What's the answer there? Tell me in a second. What are you going to punch in here? 0.6 exponent button bracket 15 divided by 7. Okay? Everybody good? So what are those 2 answers? I'll get out my calculator. That, as usual, has been thieved from me. Shocking. That one's got no batteries. What a pain. So 8 exponent bracket 2 divided by 5, close brackets. 2.29, 2.3. And what's this guy? Anybody want to offer it to me before I punch it in? 0.3. 0.33. Everybody cool? So now everybody can simplify without a calculator if they're pretty and rational, right? And if they're not rational, what's the only option available to you? Calculator, right? So now, if I am not mistaken, in your purple book, your page 89 should have this biology thing, right? Okay, you do 89 and 90 for homework. I lie, 89, 90, and 91.